Welcome to this next class. What we're going to be doing today is covering how to program bound services with respect to communication, and we're going to walk through several different models. We're going to talk about ways of programming using so-called locally bound services with the binder mechanism and extending directly from a binder object. We're going to talk about using messengers as a way to be able to send messages back from the bound services. And then finally, we're going to begin what will be a longer discussion about the use of the Android interface definition language and the binder RPC. So those will be the three different mechanisms we're going to talk about. We'll get to the first two for sure. We'll probably start the third one. The third one will go on because there's a lot of things going on there. But before we do that, let's just talk a little bit about how you program a bound service. And let's start by looking at some of the things you have to do. In many ways, programming a bound service is a lot like programming a started service in the sense that you inherit from the service-based class. And then you go ahead and start filling in a bunch of different hook methods. That's where things get different, though, because there are different set of hook methods you override for started services versus bound services. And so you have to understand the differences. And some of the differences are a little bit subtle at first, and some of them are downright confusing if you don't understand the implications of doing them. So typically, again, you'll probably override the onCreate and onDestroy methods if you have something to allocate and clean up in those methods. You may or may not need to do that, depending on what you're trying to do. And these, of course, are going to get called back at the appropriate times by Android in order to be able to initialize and terminate your service. So nothing really too deep and exciting there. Something that is more interesting is, unlike a started service where you have to override the onBind method to do nothing, to return null, for a bound service, something actually has to happen. You have to return an actual binder object from the onBind method. And you'll see later that what you return is this binder that's going to be used in order to be able to define a communication channel that the client, which is typically an activity, will use to talk to the bound service in order to pass information back and potentially forth. So things may go back and forth in a couple of different interesting ways. And you can take a look and see more about the onBind method. The onBind method is, in fact, past the intent that was called when you called bind, but oftentimes you don't really do much with that. The object that you return here is typically either created in onCreate or it's created at the class scope. You can do it either way. You can also implement unbind, and the unbind method is going to get called back when all the clients have disconnected from this particular instance of the bound service, and you haven't done some other things to take control over the life cycle of that particular service. And you'll see more about that as we go further. Typically, the onBind method returns false, but there are some circumstances where you might want it to return true if you're trying to kind of manage the ownership and the life cycle of the bound service. And if you return true from unbind, then the next time you bind to that service, it'll call onRebind rather than onBind. So there can be situations where you don't want to start over again. You want to be able to rebind because you're managing the life cycle. And if you take a look at the link that's at the bottom of this page, it goes into a bit more detail about why that's the case. And let's see. OK, so then, of course, you finally have to add the various elements and directives in your Android manifest file to indicate you want the service to be either exported or not. And if it's exported, then it's visible to other applications. If it's not exported, it's only visible to the things that are going on in this particular one. And you also have choice, of course, as to whether to run the service in a separate process or in the single process that the other activities and other elements are running in. There's a bunch of examples of how to program bound services that appear at Lars Vogel's website. You might want to take a look. He's usually got some good stuff in there to kind of get a feeling for how the whole thing fits together. So programming two-way communication with bound services is pretty straightforward. There's a bunch of hook methods that are provided, and the bulk of these are either done for you by Android, or they're things that are done by this protocol we talked about last time that the client uses to initiate connections. And we'll look a bit more in detail at that as we go on and explore a couple of different example applications. one of the most important things when you play with bound services is figuring out what kind of interface or interaction you're going to support when you return the appropriate binder object from the onBind method. And we'll see later there's a bunch of different variants that you can do to manage this. One thing you can do is you can extend the binder class, and that's what we're going to talk about first. That's for the co-located case, where you expect the client and the bound service to be in the same address space. It only works in that context because it basically shares a pointer or a reference directly back to the binder object that you're going to call from the client side, from the activity side. And we'll look at that in a second. Then you can also, if you so choose, you can also use messengers in ways not dissimilar to what we've seen before, except there's a bit more of a stylized way that you interact with stuff when you use messengers, because you're going to get the messenger back via the onBind method, whereas before you had to use some other means to pass it back and forth. And then finally, the more interesting case is to use the Android interface definition language. By the way, when we talk about messengers, we'll discuss the differences between messengers for started services and the messengers for bound services, because it's a little bit different in the way the interactions take place. All right, so let's go ahead and start talking about how we're going to handle the properties for communication for the so-called local or locally bound services. So what we're going to do here is we're going to look through this very interesting interaction diagram and kind of walk through piece by piece who calls whom and under what circumstance, and then I'll show you some sample code that illustrates how you can use this particular mechanism to implement these co-located services. There's more discussion about this. If you take a look at the website under bound services, there's some nice discussion in there about the binder mechanism, which is what we're doing here. Okay, so it's sometimes, in fact, according to the Android documentation, it's often the case that you're going to end up having a bound service that basically is used by a local activity. It's not running in a separate process, it's just running at the behest of the activity. And in this particular case, we don't want it to work across processes, so that greatly simplifies the kinds of things you have to worry about in order to be able to get the communication to work. A common name for this is co-location. So the client and the service are co-located in the same address space. And so all you have to do in this case, it's very simple, is you simply go ahead and get an instance of a binder subclass that you write, and you pass that back to the client, and then the client can use that to directly invoke methods in order to get things done. So we're going to talk about a couple different variants of this in a second, but that's the basic idea. Any questions about that? So as you can see in this particular example, we start out by having our local service, which we'll look at later, and inside of it, it's got a local binder. And that binder method is going to have a method called getService, which we'll see what that does in a second. And what it's going to do is it's going to return a reference to the service, and that'll come back over here to the binding activity through the onServiceConnectedHook method. And once we have that, then we're going to go ahead and use it to invoke method calls on the service. In this particular case, we're going to generate random numbers. Just a very simple example of a two-way call that you might invoke. That's defined on the service. Now, the onBind method has a bunch of different alternatives it can do in order to implement its behavior and return that reference back to the client. And we'll talk more about this in a second, but I'm going to step through it one at a time. So the way this starts, of course, is that the client activity calls bind service. And if you recall bind service, one of the parameters you have to pass into the bind service is a reference to a service connection. And the service connection is this little factory that's used later as part of a protocol with the service and Android runtime system in order to get back the binder object that's returned from onBind to stash it away so it can be used to go ahead and pass back the binder and manage the connection status of the service and the activity, or the client. So, of course, if the activity, if this is the first time the service is being called, it'll go ahead and be started up. Now, the onBind method has a bunch of different options on how it can return a result. One thing it can do is it can go ahead and create a binder object that contains public methods that the client can call. So you might have a specific binder that's a subclass of binder, and that's the way in which you're going to pass back the result. That's one way you can do it. And that way the client has to know about this particular binder subclass, like call it local binder, and that has to be exposed and exported back to the client. So the client has to be aware of what that signature looks like in order to call the methods on it. That's one approach. Another approach is to have the onBind method return a service instance so that it actually has public methods that the client can call. So now we're going to be calling back things directly on the service. And we're going to do some sort of variant of that in this particular assignment. And the third thing you can do is you can return an instance of another class hosted by the service that the client can call. So there's a whole bunch of different ways of being able to get something back that can ultimately be invoked by the application. So in this particular case, what we're going to do is we're going to define something called a local binder. And as you can see, local binder returns, or local binder is a binder, so it inherits the methods that binder has. And what onBind is going to do is it's going to return a reference to the local binder. And this local binder gets sent back by a call to onServiceConnected. And we'll see later when we look at the code, what's going to happen here is that onServiceConnected is going to turn around and call back to the binder, and the binder object in this case is going to have a method called getService. And what it's going to do is it's actually going to return the reference to the enclosing service. So you can see here the local binder has a method called getService that actually returns a reference to the address of the local service being the thing that encloses this. And then what that'll do is get that reference, and then it's going to stash it away on the client side as a callback. So you'll end up with a method that the client is going to store, and that client activity will then use that in order to invoke an operation that's defined on the local service. Now again, you don't have to do it that way. We could have it return a binder that itself would have the method that we want. In this particular case, the method we're going to end up calling is called getRand. It's going to get a random number. But we could, and it's defined on the service, but we could also move that into the context of the binder. Lots and lots of different ways to do this. But the most important thing to remember in all this stuff is that these things have to be co-located. You can't be passing things around if they run in a different address space. The getRand method is just a simple Java method that, when called, returns a random number between within a range. And so we'll see how you initialize that in just a second. And that's a two-way call. So that means that the client activity blocks while that call is running, and when the call is finished, it returns the result back to the caller. Keep that in mind. Obviously, for something as simple as co-located communication in the same address space, this just devolves into a function call. So it's really fast. There's not much point in trying to use fancy concurrency mechanisms or other forms of communication in order to be able to get that result back. When we start moving things so that some of the behavior runs in a separate process and maybe takes longer to run than getting the next random number, then it becomes important to think about the consequences of blocking for some period of time. Any questions about that? And you all know why blocking is bad, because that can trigger the dreaded ANR method. Okay, so let's take a look and see how you might actually write this code. We'll kind of walk through it a little bit at a time. So what we're going to do here, here's our local service. Local service extends service. And as I showed you before, local service has a nested a class inside of it called local binder, and local binder extends binder. And local binder defines a factory method that is going to return the local service. Oops, a little bit of a typo here. So as you can see, local service, the local binder, has a getService method, which when called returns a reference to the enclosing service in which it's nested. And so that method will just say return local service.this. Any questions? So we're getting back the address of the service. Now again, as I mentioned before, if there's some reason you don't want to do that, then you would probably put all the interesting methods you want to implement inside of local binder and then return that. So there's a couple different ways to do this. No one way is right or wrong, just different ways of doing it. We then go ahead and create a local create an instance of local binder. And you can see that this is done at class scope. So in this particular case, we don't have an onCreate method because we're initializing this in the context of the class. When the class is created, that constructor or that new will be called. It'll get ourselves an instance of local binder. That'll get stashed away in mBinder. And then when the client calls bind service, that'll trigger onBind to get called back. And you can see all that'll do is just return mBinder. So it returns the binder back at that point. So now, if you recall, what's going to happen is the client side will have its onServiceConnected method called, which we're going to look at in just a second. And that's going to stash away this particular binder reference, and then it'll use it henceforth to do the next step in the processing sequence. Then there's also this method called getRand. GetRand is a public method, so it can be called by anybody who has a reference to the service. How are you going to get a reference to the local service? Well, of course, the getService method, which is a factory method, is going to give it back to the client, and the client can then use that reference in order to call the getRand method. And as you can see here, the getRand method simply goes ahead and generates you the next int between 0 and 100, randomly, the next random number in that range. Any questions about that so far? Pretty straightforward. This is really simple. In some ways, this is just an awful lot of work to get yourself an instance of an object to invoke methods on. Right? It's basically a bunch of factories and a protocol that are taking place in order to set things up so you get yourself a reference you can invoke. I'm starting with a simple case because the more complicated case is simply a generalization of that with some more machinery involved using things like messengers and or AIDL and the binder. Let's take a look at the activity. In this case, we have something called binding activity. Not particularly interesting name, just give it a name. And it starts out with some state. One piece of state, of course, is going to be the reference to the local service it's going to get back as part of this protocol. It'll engage in. We'll look at that on the next slide. And it'll also keep track of a flag it's going to use to make sure that the actual binding has taken place and has succeeded before we start trying to go ahead and invoke methods. Let's now take a look at the onStart and onStop methods. When these methods get called, that's what's going to set up the binding to the service. So as you can see, when onStart gets called, and you all remember when onStart gets called when the activity is about ready to resume. And what we do in this case is we go ahead and create ourselves a new intent pointing to the local service class, which had better be in our address space. And then we say, hey, please bind this intent and pass in this service connection instance. And we'll see where that comes from later. That's defined a little further down in the file. Here's the onStop method. What the onStop method does is if the service is bound, then we go ahead and we unbind it. And of course, if we're the last one to unbind, then that'll cause the service's unbind method to get called, and it'll get shut down. The last method here is, the last method here is just the one that does something when you click a button. So when you click a button, what it's going to go ahead and do is it's going to go ahead and pop up a toast that's going to show the random number, the next random number that you get back from the local service. So this call right here, and I guess I should probably augment the slide to say that. This particular thing calls the service method. So this is the guy that actually calls in there in order to be able to get the random number. And that's a call into the service. Again, it's in the same address space, but it's a call nonetheless. Okay, any questions about that? Pretty straightforward. The last piece of the puzzle is the connection. This is the service connection. This is the guy that's used to keep track of whether or not the client, in this case an activity, is connected to the bound service. And you recall you pass this M connection into the bind service call, so it knows what to use to set the connection up. And once the connection is established and the Android framework, the runtime system, has successfully gotten back the binder object from calling onBind on the service, it then goes ahead and calls back on onServiceConnected. And what onServiceConnected does, as you can see, is it downcasts the service it gets to be the local binder, because that's what this type actually is. It's using downcasting here because it has to have an interface that uses the base interface, and yet we've passed back a concrete derived interface or derived class. And then once we do that, then we go ahead and call binder.getService. This call right here is a factory method, and that factory method, as you recall, calls back over to here and ends up calling getService, which returns the reference to the underlying service. So once we've done that, we now have the mService reference. As you can see over here, mService is what's used when you click the button later to get the random number generator, to generate the random number. So we're basically initializing this. And we're also noting that we are now bound. So we've now said we're bound to the client, and therefore when someone does the click, the call will actually be attempted. If you haven't finished binding and someone tries to click, then obviously you don't want that to dispatch because you're going to get a weird result because it hasn't been bound yet. If for some strange reason the service is unexpectedly disconnected, then we go ahead and say, basically on service disconnected, and then we say we're not bound anymore. So in that case, we aren't going to try to reestablish stuff, or we're not going to try to go ahead and do the call if we're not bound. Okay, any questions about any of that? Believe it or not, that's actually the simple case. And the reason why it's a simple case is because there's no networking, there's no distribution, there's no separate processes. It's all glommed together in the same address space. But what you can see from this example is kind of the pure form of the framework. All the other things are the same. It's all the same callbacks and all the same model. It's just that you end up with objects that you're invoking through local method calls. So you would typically use the local binder approach when the service is just playing the role of a background worker for an activity. So that's the only thing it does. And again, according to the Android documentation, this is used pretty frequently throughout Android, so it's not an uncommon use case. The nice thing about it is it gives you the building blocks to do the more complicated use cases that are more interesting but more complex. And in this case, everything has to run within the same address space. The only reason not to do this, the only reason why you would prefer to do something more powerful, would be either because you want the service to be reused by other activities. It's not just a slave to the one activity that's starting it here, but it's meant to be used more broadly, or because you need to be able to dispatch things across separate address spaces. So the local binder approach is not going to work, not going to scale, and you'll have to use something more powerful, which we're going to talk about next. Another thing to keep in mind here, and we'll come back and talk about this later because it's a little bit subtle, notice that when you invoke a method, when you do something like we showed back here, where you say mService.getRand, or I think as we showed over here, binder.getService, those method invocations actually are dispatched in the same thread of control as the calling thread. So the thread that implements getRand, or the thread that implements getService, is the same thread that called it. It just borrows the thread for the duration of the call. So that's another important thing to keep in the back of your mind. Why do I mention that now? Because when we start talking about the more advanced mechanisms that involve communicating between processes, it's not going to be the same thread of control. In fact, it's going to be a thread coming out of a pool of threads that are managed by the underlying binder mechanism. And we're going to talk about that shortly. Okay, any questions about this stuff? Very straightforward, good place to start if you want to see how the pieces fit together. You won't have to program this in your assignment, so that's just there for you to learn. The next example we're going to talk about is the next level up. It's more generalizable. This particular example we're going to look at here isn't much more powerful. In fact, in some ways it's less powerful because the particular example we're going to look at in detail only supports one-way communication. But what's nice about what I'm going to show you is it's easy to generalize this to support two-way communication and communication that takes place between processes. This particular example does not try to communicate between processes, but you can easily extend it to do that. This example, or this discussion, takes place based on some stuff you can find at the website, the Android website, where they talk about messengers. So you guys probably remember messengers we talked about before. When we talked about messengers from started services, Do you remember how the messengers were communicated in the first place? What was the means by which you got a messenger from one side to the other? Right. You basically bundled the messenger inside of an extra in the intent. So you take that thing, stick it in a name like messenger or my messenger or whatever you wanted to call it, stick it in the intent, and when you did start service, that intent was used to send the messenger over to the service. And then you would pry out that messenger by calling get extra, and you'd retrieve the particular messenger, and then you'd call a call, and the call would go back to the activity. So if you recall, our original purpose for using messengers was to allow the service to call back to the activity in order to let it know something had happened. In this particular scenario, we're going to reverse the roles. So now what we're going to do is we're going to end up getting back a messenger from the bound service using that little protocol we were looking at. And so what we're going to get back, as we'll see in a second, is something that's going to allow us to be able to get back a messenger, and then the client side, the activity, will use that messenger to send work over to the service. So it's almost an inverse way of doing things, but it has some stuff that's kind of in common. Now, why would you ever want to do this stuff? Well, one reason why you want to do this stuff is if you wanted to be able to communicate from an activity or a service to a bound service without going to the trouble of understanding how AIDL works, AIDL being the Android Interface Definition Language, which is a more powerful set of mechanisms, but also more complicated. So if you just have a very little bit of things to send, or you like the message passing paradigm, then this approach may work very well. And as I mentioned before, it's easy to generalize this to work between processes, even though we're just showing it for a single process right now. So we start out here by basically sending an intent using bind service, and if the service is not running, it gets started, nothing new there. Now we're going to do things a little bit differently. This is kind of interesting. So what we're going to do in our service is we're going to implement a handler. And this handler is going to be used by the service to receive calls that come in from the activity. Well, how's that going to happen? Well, what's going to happen is we're going to go ahead and create a handler, and then we're going to encapsulate that handler inside of a messenger, just like we did before, except this time it's on the services side, not the activity side. So you can see here what will happen is that the onBind method is going to say, hey messenger, please return a reference to yourself as a binder, which is kind of a funky thing to do. But it turns out that they've got mechanisms built into Android that know how to take messengers and get back binders for them, as well as take binders and associate them with messengers. So you can go either direction. So that's what we're using here. So the onBind method says, hey messenger, get me your binder and return that back to the caller, please. That, of course, comes back as a dispatch to the onServiceConnected method. And we're going to go ahead and grab that thing out and stick it into some kind of local data member. And then later, whenever we feel like it, when someone clicks a button or timer passes or the phase of the moon gets to the point we want, we then go ahead and call the send method on this messenger. And of course, we can also pack whatever messages we want to have in there through extras or other things. And that'll then go ahead, or not as extras, but as data that you put into the message. And then that goes ahead and gets dispatched back to the handler running in the context of the service. So you guys should start to see some commonality. If you think back to all the things we've talked about since we first started talking about concurrency in Android, common theme, recurring idiom in Android is to create a handler and have that handler handle messages that are sent to it, right? And then be able to have somebody send messages to the handler. When we first looked at concurrency in Android, if you recall, we didn't worry about things that were in separate address spaces. They were always in the same address space. So what you would do is you would have a handler, and you would subclass it, you would fill in the handle message method, and then you'd get a reference to that handler, and you'd say send message, and it would, voila, it would show up somehow in that other thread where the handler was being run by the event loop. Once we start getting into services, and we want activities to talk to services, or services to talk to services, and so on, all of a sudden we need a little bit more mechanism. So messengers become a way of encapsulating handlers via a means that allows them to be accessed from other processes or other contexts. In this particular case, an activity is accessing a service, a bound service, in the same process, but the point generalizes. Any questions about that? So that's kind of cool. Let's now take a look at how you would implement this code. So the nice thing about this is it's very, very similar to things we've looked at before. It's just that we have to move a few things around to get the appropriate references returned at the appropriate times by the appropriate hook methods as part of the appropriate framework of callbacks, all of which are managed for you by Android. So we're going to start off by having a messenger service, which is a service. It extends service. It defines an action called message perform action, which is a pretty boring name, but it does something or other. We don't really care what. The service knows what that means, though, so it knows whenever someone passes this type of message to it, it'll take some action with the message. And then down here, we have an in handler for input handler, and that extends messenger. And you can see its handle message callback, when called, checks to see what we've been sent, and if we've been sent the message perform action message, we process the message somehow. So we'll leave that up to your imagination as to what we might do, but that's basically how it works. So that's the handler for the incoming messages. Then keep in mind we're still inside the service side, the bound service side. We then go ahead and create a local data member that we initialize called end messenger of type messenger. And we make this guy to be a new messenger, and he encapsulates the handler. He encapsulates a new instance of this particular handler. And as you can see here, in this particular case, there's actually a reference, there's actually a constructor that takes a handler and goes ahead and makes a messenger out of that. And I just realized I got to fix my animation here. It should come up one, I think. There we go. So what will happen in this particular case is that the messenger we create will encapsulate the handler, and the handler is the guy that actually does the work. And then the final thing that happens, as we saw before, is the onBind hook method, which gets called back by the Android framework, will say, hey messenger, give me back your binder, and I will pass that back to the client. We'll look at see what the client does in just a second. Any questions about this? A couple of things to note. One thing to note is it's always pretty much done exactly the same way, right? So there's a set of idioms that you always see Android do. The second thing to note, though, is there's a lot of busy work going on here. There's a lot of things you got to remember to do. You got to remember to make a handler. You got to remember to subclass from the handler. You got to remember to fill in the handle message method. You got to make sure that you create a messenger and you encapsulate the handler in there. There's an awful lot of this kind of grubby work. And then you also have to basically deal with all the different types of messages that can get sent back and forth. For something as simple as this, it's pretty easy to keep track of the one message perform action operation that you want to have done. In real life, you might have lots more things to do. So the thing to keep in the back of your head is even though messengers are real simple in terms of each piece is easy, the composition of the pieces, especially at scale, can get unwieldy. And remember that when we motivate the next mechanism, which is the Android interface definition language, which cleans up a lot of that stuff for you. Here then is the messenger activity. This guy goes ahead and creates a reference to the messenger, which it's going to use to send stuff to the service, keeps track of whether it's bound or not. Then basically we have this, on service connected. On service connected gets called, recall, by the Android runtime when onBind returns successfully. What does onBind give you back? onBind gives you back the binder. What does on service connected do? When it gets called back, it goes ahead and it takes that binder and it wraps it back in a messenger again. This is kind of funky, right? Over here, we had a messenger on the server side, and we got a binder from it, and we sent the binder back. And then about the first thing we do on the other side when the onServiceConnected method gets called is we turn around and we say, remember that binder you sent me back? We'll make a messenger out of it again. Right? So this is the kind of stuff you have to do. It's not hard, but it just is tedious, and it's easy to forget, and something will go wrong. So in this particular case, we now have our messenger, which has been initialized to the one we got back from the service through the onServiceConnected factory method, which is called back when things are bound. We note that we're bound, and then of course if we get disconnected we have to clean ourselves up and not let anybody dispatch stuff till we're reconnected. Here then is where everything actually gets driven. So someone will, when the onStart gets called, when this activity is coming back into existence or it's just starting up, that'll cause us to go ahead and do the binding to the service, passing in the connection that we just looked at. On stop basically unbinds things if we're going to be going away. And finally, we have the on button click message. So you can see what on button click does is when it's called, it goes ahead and it makes a message, fills in stuff. I guess it should actually say message perform action, because that's what it's doing. It goes ahead and creates the message perform action method. And then it says, hey, messenger that I've got a proxy to in my address space, I'd like to go ahead and send you this message I just made. And of course, you could put other things in the message besides just the action. You could put data and other information in there. And that will then go ahead and send that message. And that message, of course, will show up over here to be dispatched back by the handle message method defined in this particular in handler or input handler. Okay, any questions about that? So you can see there's a bunch of moving parts, but once you understand the basic idea of handlers and messengers that encapsulate the handlers and ways of grabbing binders out of messengers and passing them across via the on-service connected and on-bind hook methods dispatched by the Android framework and then reconstituting things as a proxy, it all kind of fits together and becomes very common after a while. Now, what I just showed you there was a simple one-way approach where what is happening is we're getting back a messenger in the activity, and the activity is using that to call something in the service and send it something to do. It sends it a message. If we want to do two-way communication, it's pretty simple, but again, it requires some more work. What you're going to have to do in that case is you're going to have to go ahead and pass another messenger along with the first message. You're going to have to create something that will tack on the messenger with the original message. That'll then get sent over to the service side where it'll be reconstituted back to a message, and then you go ahead and have the services side dispatch the reply by calling send on the reply handler. So you'll have a reply handler message which will then go ahead and take the handle message back. So there's a few more steps. You'd have to find that reply handler on the activity side, and you have to create another message and encapsulate the handler in the message and pass that with the message you were sending over, blah, blah, blah. So there's a number of steps. This is where the messenger-based approach starts to become complicated. If you end up with message passing that requires two-way interactions, it can get a little bit unwieldy. It's not hard, it just requires keeping track of a bunch more things. And we'll see in a second when we start talking about the next approach that hides, that next approach, AIDL-based approach, hides a lot of those details from you. Questions, comments? We don't actually show the code here, but it's a simple extension and not hard to do. So if you want to be able to do message passing based communication, that is send messages back and forth and make them very dynamic and so on, then the messenger style may be the one for you. It allows us to be able to do all this inter-process communication without having to learn how AIDL works, which is arguably easier sometimes, but it's arguably harder sometimes too. Undoubtedly, a good quiz question for next quiz will be compare and contrast the use of messengers and AIDL along a number of dimensions and decide when you would use which one. The answer to some of those questions, by the way, can be found by reading the documentation for the AIDL type or the AIDL feature in Android, because it has those kinds of discussions in there. If you want to be able to do communication across address spaces, then to do inter-process communication, there's some additional work you have to do. It's not that much harder. You just have to be able to put things in bundles and pass them around so they can be reconstituted correctly. Another thing to note, messengers queue incoming calls, because keep in mind that they have those handlers, and those queue up the work, just like we talked about when we were talking about the concurrency models with Android, where you have like the looper thread. This would be the main looper thread in the service, or the activity. So those things get queued up. So what this means is if you use the messengers I've shown you here, and you don't spawn extra background threads and run loopers in them, if you just use whatever comes out of the box, then you don't have to worry about making your code thread safe. You don't have to put synchronization in it. You don't have to use the various monitor kinds of things we talked about before when we talked about Java concurrency. Everything will be dispatched one message call at a time by the normal looper. Any questions about that? Now that's very important to remember because the next thing we're about to talk about doesn't have that property. So the nice thing here is you can keep it fairly simple. If you need to have a multi-threaded service, if you want your service to be able to run things in multiple threads, then you're going to have to go to the next step, either by using an intent service that we talked about before, or by going to the full-blown AIDL mechanism that we're about to talk about. Okay, so in the time remaining, what I'm going to do is I'm going to start giving you an overview of AIDL and its supporting infrastructure called the binder remote procedure call mechanism. And we'll talk a bit about how it all works, why you need it in the first place, and then we'll probably get to the discussion about the supported types, and that'll be the end for today. Then we'll cover more of that stuff on Wednesday. And this will give you, by the time we're done on Wednesday, you should have enough information in order to be able to do your programming assignment. So I strongly recommend you start as soon as you can. So what we're going to cover here is we're going to talk about all the things that go on in this wonderfully colorful and detailed diagram, and I'll break them down one step at a time and explain how it all works. AIDL and binder RPC are the most powerful local inter-process communication mechanisms in Android. They let you do a lot of interesting things. Once you master what is actually not that much complexity, you'll find it's probably the right way to go for a lot of things. There are certain cases where it's overkill, but it's often the right thing to do. And once you learn it, you'll find it's not that much different from programming normal interactions by invoking methods on objects. In fact, that's kind of the whole point, is to make it look very object-oriented in its semantics and its performance. So let's first talk, why do we need this stuff in the first place? Why do we need an Android interface definition language? Why do we need this thing called the binder RPC? Well, one of the reasons is that unless you use something really fancy like what Zach showed us a couple of weeks ago, you don't have an easy way to be able to have one process in Android access something in another process. If you use shared memory, then yes, but that's a very, very specialized case. In our previous two examples, where we were talking about the local binding and the messengers, we kind of sidestepped this issue a little bit by keeping everything in the same address space. So you could actually just pass regular references to regular objects, and they just work magically because of the way in which that works in the same address space all the time. That's just object-oriented programming. So when you want to communicate between processes, you have to go a little further. You have to figure out a way to be able to decompose the contents of your objects, which themselves might be references to other objects, by the way. Compose these things into primitives that the operating system can understand, because it's Linux under the hood after all. And then you want to be able to marshal and demarshal these objects across the process boundary. So marshaling is a fancy name for converting or transforming data in a native format, in this case Java. In Java, Java ints, Java longs, Java shorts, Java arrays, and so on, Java sequences, and so on. And then turning those into something that can be passed over to another address space. That's marshaling. And you can see here for more information about marshaling. And then demarshaling is the opposite. That's taking all of that data out of a linearized buffer and then reconstituting the appropriate objects. Now, usually in computing, we use marshaling and demarshaling when there's a potential of talking between a client and a server that are running on different machines, and the machines may have different compilers, different alignment rules, different byte orders in the hardware level or the compiler level, and so on. That's obviously not going on in Android per se. We're always running in the same address, in the same machine, in the same computer. Which reminds me, Scott, don't leave without taking the thing I have for you. So at first glance you might think, well, they're always going to be the same processor. Why do we need to do this? The reason is various. One thing you can do in Android, as we'll see here in a second, you can actually talk between a Java activity and a C++ or C service. So there's maybe a need to cross language boundaries. Moreover, some of the things you want to send around, things like object references, are not easily transformed just into a simple pointer. You actually have to do some machinery in order to be able to make sure you do the appropriate checking on the receiver side to do the Java security model and so on. So marshaling and demarshaling are these processes of linearizing data from native form into some linearized form, sending that around, and then reconstituting it. So marshaling is from native form to linearized form Demarshalling is from linearized form into native form. And those are the interactions that take place. You definitely run into this when you start programming distributed systems, but even in Android, for a variety of reasons that we just talked about, like different languages interoperating with each other, the semantics of Java and so on, we have to do something more than just pass raw pointers around. Now, the code to do this is usually not very complicated, but it's very tedious, because what you have to do is you have to take every field that exists in the object and convert it from its native form into this linearized form. And that just takes patience, and it's easy to get things wrong. So to make life easier, Android defines a language to help you do that. And the language is called the Android Interface Definition Language. And it's very similar to Java interfaces, though it's not identical, as we'll see in a second. So here's a very simple example. We have this iDownload interface. And as you can see, the iDownload interface has a download image method. It could have other methods too. It takes a string and it returns a string. So it's going to take the URI as one of the fields, and it's going to give back the path name as the return value. The compilation converting this interface from AIDL into Java and then doing all the necessary things in order to make this work under the hood to carry out all the steps, that's done by something called the AIDL compiler. I can see I need to tweak my slides in various places. So the AIDL compiler is a tool that runs under the hood, and that's used to transform the AIDL, which is this interface definition language-like syntax, into so-called proxies, which are the things that are on the activity side of the client side, and stubs, which are the things that are on the service side or the receiving side. Just to be confusing as heck, because there's lots of different names for this stuff. Some languages call them proxy stubs and skeletons. Sometimes people talk about client-side stubs, server-side stubs. Android kind of invented their own term, proxy and stub. Those are the names that they use. And if you take a look at this website, you'll find out lots of more about all the things we're talking about. So that's how we get things in a format that can be sent. But then how do they actually get sent? Well, they get sent by using something called the binder remote procedural mechanism, the binder RPC. And it basically gives you this way of being able to send communication across through the backplane of the operating system. And we'll talk more about that in a second, see how that works. You pretty much never touch the binder directly. It's almost invariably hidden from you by the code that's generated by AIDL and other runtime code that's provided for you by the framework. It's like the services framework we were just looking at. Hide you from those details. If you want to find out all kinds of fun information about the Android binder and AIDL, take a look at this link. Many, many articles, lots of good tutorials, lots of great videos, slide sets. If you really want to dive into this stuff and really know how it works on the inside, there's some good places to look there. We're going to cover some of that, but there's plenty more to learn about if you're really interested. Speaking of details, let's talk about some of these details. So this is how things actually work if you start peeking under the hood. Under the hood, the binder mechanism is actually implemented by a driver that's part of Linux. It's an extension that was added to Linux by the Android developers at Google with help from other folks, and they basically provide it as a driver, and it's meant to be able to be very high performance. It uses shared memory to move data back and forth without having to copy it very much, and it also uses a pool of threads in order to be able to maximize the throughput without having to block waiting for stuff to finish, which of course works really well on modern multi-core machines. The Android system services, or services you write for that matter, are often written in C and C++ for performance. You'll see a lot of things like the media player is written largely in C++. And so they use these service mechanisms, which is one reason why we need to have this IDL mechanism in order to be able to convert things from native format, which could be C++ or C, into a linearized language and address space independent format, and then reconstitute it back into another format that's understood by Java in another address space. So that's why we have to do all this stuff. And there are many services, if you poke around, you see lots of examples of how those things exist. If you take a look at one of the classic Android videos that gives the overview of the whole architecture, they have some good examples of how this stuff works and different things written in different languages and so on. The caller's data is marshaled into parcels. These are copied to the callees processed and then demarshaled into what the callee expects. This marshalling and demarshalling is what's done by this generated proxy and stub code that comes out of the AIDL compiler. We'll look at that code next time. I'll actually show you what it looks like. You'll very quickly see why it's great that somebody is generating that code for you, because it's really, really low level and tedious and ugly. By default, what you get if you don't do anything else is you get two-way call semantics. And what that means is you invoke the method synchronously, which just is a fancy way of saying the caller blocks until the callee, the service, is done processing the request and returns with the return value. And we'll talk more about the types of data that can be passed shortly. There's another variant of this called one-way invocations. One-way invocations do not block. So you can declare them a couple of different ways. We'll look at that later. But a one-way invocation says this call won't block. So normally you make a call, it blocks waiting for the results. The other way to do this is to use two interfaces, each of which use one-way calls. And this can be used to implement asynchronous communication. You'll get a chance to do this for your next assignment. So in your next assignment, you're going to do the synchronous approach, and you're also going to do the asynchronous approach. And we'll compare and contrast why you would pick one versus the other. In the asynchronous approach, what you do is you create some kind of reply handler object, and you have an IDL interface that you can use to set the callback. So what you do is you pass a callback to an object that lives in your client activity, and you pass it to the service. The client doesn't have to wait in that case. It just goes on and does whatever it's going to do. The service processes the request, and when it's done, it takes the callback object that it got from the client, and it invokes a one-way operation on that in order to send the reply. In this case, it's going to send back the path. If we're downloading files, it'll send back the path name after it downloaded the file. So that's an interesting approach that doesn't require blocking. Servers typically handle both one-way and two-way requests out of a thread pool. I say typically because if you co-locate these things, like we talked about before, then there is no thread pool. But in the normal case where they're distributed, or not distributed, they're in different processes on the same device, in that case there's a pool of threads. And that means that you have to be very careful that you have thread-safe code, because these callbacks will be taking place in a manner that will be in different threads. And if they access shared state, that state can easily get corrupted. Now, at this point, you guys hopefully know a bunch of different mechanisms to manage that. So the monitor object stuff we talked about, some of the more powerful freestanding synchronization mechanisms that Java provides, like mutexes and semaphores and so on and so forth. But you have to make sure that you are responsible for keeping track of that state and protecting it. So to wrap this discussion up, Android provides a whole range of inter-process communication mechanisms to communicate with bound services. You can learn about all this stuff either online or by various books. I usually do a combination of things. AIDL is a language that allows you to be able to define binder-based services that are going to be bound. So you typically or invariably you use AIDL with bound services. It works really well for that. And by combining it with the binder IPC mechanisms that are available in Android, we can use this in order to implement the broker pattern. So the broker pattern is a very important pattern. We're going to talk a lot more about it later. I'll go to it in detail. But for right now, the broker pattern is basically a pattern that allows clients and services, or clients and objects, to communicate across address spaces, maybe on the same machine, maybe across a network. In Android's case, it's across the same machine, or in the same machine, in order to be able to allow communication to take place that looks like method calls on normal objects, but in fact shields the application code from all the low-level details of connection management, data transfer, memory management, synchronization, concurrency, fault tolerance, et cetera, et cetera. All those things are handled by the broker. And so the underlying binder RPC mechanism, coupled with AIDL and the stubs and proxies that are generated by the AIDL compiler, it allows us to implement the broker pattern. There's a whole pile of other patterns involved here as well. Proxy, adapter, activator, etc. And we're going to talk about all those patterns. Probably once we get through this Wednesday's class, where I will have covered the remaining parts that you need for your programming assignment, then we're going to take a week or so and just cover all the patterns. We have a whole pile of patterns that have kind of queued up here I want to go through to make sure you understand the pattern-oriented dimensions of what we're doing. Okay, any questions about any of that stuff? So I think I'm going to stop here, but let me just cover a few things before we wrap up. So what we're going to talk about next is we're going to talk about the various mechanisms that Android provides, AIDL provides, in terms of what interface features it supports. You'll see that AIDL interfaces look suspiciously like Java interfaces with a whole bunch of restrictions. So they have some things in common with Java interfaces. There are ways of defining methods, but they have a lot of other things that are missing. So they're not, one-to-one replaceable, but they get you in the basic vicinity of a Java interface in large measure. And we're going to talk about the various data types they support. They support all the basic data types. They also support some other things like arrays and lists and maps and something called parsables, which can be used to take any arbitrary class and make it something you can use with AIDL if you so are inclined to fill in the right methods. So then first we're going to cover what AIDL does, and then I'm going to look at a couple of different examples related to the kind of thing that you'll be doing for your programming assignment, looking at synchronous and asynchronous communication using AIDL and the binder mechanism. And that'll give us a chance to kind of see how you really program this stuff. We're going to take a look and see what kind of code is actually generated by the AIDL compiler. Not because you necessarily have to know what it does, but it's just interesting to see how it works. And it gives you this great feeling that you don't have to write that code anymore, which is nice. And I think after that, then all we have left in this whole discussion will be the patterns. So I think by the end of next week, we will probably have covered all the binder mechanisms. We will have talked about services. We will have talked about communication between activities and services and so on. And then we'll be in a position to start talking about the next big chunk of the course, which is the part that relates to content providers and data management. And you see that those are really the main things that are left. So that'll get us basically into probably mid-November-ish or so, and we'll have a couple more programming assignments between now and then. Questions?